All right, so what does a rational equation look like? Basically, it's f of x equals to a of x over b of x. So basically, you have an expression divided by another expression, okay? Now, for vertical asymptotes, you have to make sure that the function is simplified with no common factors, all right? So what does that mean? So suppose I have f of x is equal to x plus 1, x plus 2 over x minus 3, x plus 1, okay? Are there any common factors between the numerator and the denominator? Yes, the x plus 1, right? So once we get rid of those and what remains in the denominator is stuff that can't go away, that's when we start looking for vertical asymptotes, okay? Vertical asymptotes are pretty straightforward to find. You basically set the denominator equal to 0 and then you solve for x. Okay, that's all. Now, how about horizontal asymptotes? To find a horizontal asymptote, there are 3 cases. The first is if the degree, what's degree? What's that term mean, degree? Not coefficient. Which exponent? Lowest, highest, middle? Okay, so if the highest exponent, if the degree of the numerator is greater than the degree of the denominator, okay, then there is no horizontal asymptote. So for example, if you have y is equal to x squared plus 7 over x minus 1, the degree in the numerator is greater, there is no horizontal asymptote. It's just as simple as that. Okay, number 2. Okay, what if the degree of the numerator is less than the degree of the denominator? Then the horizontal asymptote is just y equals 0. So suppose, for example, you have y equals 3x squared plus 7 over x cubed minus 4. Okay, the degree in the denominator is higher. Do you see that? That means, no questions asked, the horizontal asymptote is just y equals 0. Okay, the third case is, okay, what if the degree of the numerator equals the degree of the denominator? Then what you do is you take the term with the highest exponent from the top and the bottom, and you just divide them. So for example, suppose you have f of x equal to 3x squared plus 7 over 2x squared minus 1. Okay? What you do is, for the horizontal asymptote, you say y equals, okay, you take the term with the highest degree. That's the whole thing. 3x squared over 2x squared. What happens to the x squares? They cancel, so you just get y equals 3 over 2. And that's the horizontal asymptote. Okay? So you can see some examples here of vertical and horizontal asymptotes. In the first case, there is no horizontal one, just a vertical. Here you have 2 vertical and a horizontal. Here you have 1 vertical, 1 horizontal. 2 things that I want you to note. In each case, it's to state the asymptote, it's an equation. X equals 1 or x equals -1 or y equals 0, y equals 2. If you don't put the variable, I do take points off, just like I did in the exponential graphing chapter. Okay. One other thing is, look at the vertical asymptotes. Okay, in most cases, it's like those old like those video games like Pac-Man. Remember in Pac-Man, like if a character exits the screen from one side, it re-enters from the other side? It's the same thing here. If it exits here, okay, to the right, then it re-enters from the bottom to the left of it. Okay, look, same here. Exits here, re-enters from the bottom. Exits here, re-enters from the top. You see that? So if it exits on the top, it re-enters from the bottom. It exits from the bottom, it re-enters from the top. We're going to use that in a little bit to graph. It's just that's how asymptotes work most of the time. Yeah. All right, so take a look at this first function. So first we want to find the zeros, and I've told you how to do it. I'll tell you in the notes, but not on the test. You have to set the numerator equal to 0 to find the zeros, okay? So here we say x cubed is equal to 0. That means x is equal to what? 0. Okay, that's a 0. Okay, let's find vertical asymptotes. Take a look at what's in the denominator, the x plus 1. Does it cancel with anything in the numerator? No. So that x plus 1 gives us a vertical asymptote. So to find the vertical asymptote, remember I set the denominator equal to 0. So I say x plus 1 equals 0, and x just equals negative 1. Vertical. Okay?
What if there's no variable, then how do you set it equal to 0?
Then there is no asymptote. Okay, thank you for raising your hand, but then there is no asymptote. Okay? Horizontal asymptotes. All right, so for horizontal asymptotes, we have to compare the degree from the numerator with the degree from the denominator. Okay, so what's the degree here in the numerator? 3. And here? 1. And if the degree in the numerator is higher, what does that mean about asymptotes, horizontal asymptotes? No horizontal asymptote. So we just say none because the degree in the numerator is higher. Okay. Now I'm going to graph this. To graph, first I put in what I just found. Okay, so x equals 0 is here. X equals negative 1 is a vertical asymptote here. And there are no horizontal asymptotes. Okay? Now, most of the time, we don't need to pick points. You'll know exactly what it'll look like. But when you only have one asymptote, it's a little bit more difficult. We're just going to pick points. Yes?
Is there a reason you're saying higher and not bigger? Wouldn't you say bigger?
Well, numbers are higher or lower. Technically, it's greater than and less than. But that's the same. Okay, so we're going to pick some points. We're going to pick x equals 2, 3, let's do 5. And let's do some on the other side of the asymptote. So negative 2, negative 4 maybe, okay? My function is x cubed over x plus 1. Okay, so you're going to help me out with this. When I put 2 in here, I get 2 cubed, 8 over 3, which is 2 and 2/3, right? So it's 2.7. Okay, when I put 3 in here, I get 3 cubed is 27 over 4. How much is that? About. How much? It's about 7, right? So it's like 6 point what? 6.75? Awesome. Okay, so what if I put 5 in there? That's 125 over 6. How much is that? That's a big number. Anybody? 125 over 6? 20.8? Okay, now when I put negative 2 in here, I get negative 8 over negative 1, which is just 8. When I put negative 4 How much does that give me? So negative 64 over negative 3, that's a positive number. How much is that? 21.3. Okay, so take a look at this. Okay, so let's just plot these points. So 2, we're at 2.7. 3, we're at 6.75. 5, it's 20.8, so it goes up really, really high, right? So here it looks like it's going up pretty high like that, yes? Now what happens between the point and the asymptote? Well, it's got to follow that asymptote down here. Okay, so it goes down there. Does that work with everybody? Right next to it. I'm trying to get it to the right amount of closeness here. Okay? Now, what did we say? This is a 0. So if it comes here, it's got to cross the x-axis because that's a 0. It's going to cross and it's going to follow the asymptote and go down. Now, what did we say? If it exits the screen here, it's got to re-enter from up there, right? What are the points we got there? At -2, it was at 8. And where is it at -4? Like 21.3, way up there. So what did we say? We said it's going to come down from this side. Okay? We know that. Now, we also know that it's going to cross this. Are there any other zeros here? Yes or no? Did we find any other zeros? No. That means, is it going to cross the x-axis here? No. But it's going to hit that point. How could it possibly hit that point? What does it have to do somewhere around here? Turn back around. So you make it turn back around and hit that point. How do you know where it turns around? I'm not concerned about that. I just want you to have the correct form. Okay? 2 and 8. Huh? Huh? Once it exits the screen here, it's got to re-enter from the opposite side, so from the left side of the asymptote. Hannah. Okay, so here, we're going to factor this first. So how does this factor? X plus 5, x minus 1. Now, to find the zeros, we set the numerator equal to 0. Does that work? 5 can never equal 0, so that means there are no zeros. What does that mean? Where does it cross the x-axis? It does not cross the x-axis. Okay, vertical asymptotes. Do any of these terms that we factored in the denominator cancel with anything in the numerator? No. That means we cannot make them go away. That means both of them can qualify as vertical asymptotes, okay? So, we're going to see later on what happens if they did cancel. If the denominator does not to find the zeros, you have to set the numerator equal to 0. We just have 5 equal to 0. Okay, so as long as it doesn't cancel from the denominator, you can use it to find a vertical asymptote. Is there another x plus 5 on top here for it to cancel? No. As long as the stuff here don't cancel, you can use them for vertical asymptote. You'll see later what happens if they do. Okay? So x equals -5, x equals 1. Those are your two vertical asymptotes. Okay, horizontal asymptotes. What's the degree in the numerator? Not 1. 0. Because it's like x to the power of 0. Okay, what's anything to the power of 0? 1. Okay, and what's the degree here? Degree is 2. What happens if the denominator has a higher degree? What's the asymptote? not 0, y equals 0. Okay? Y equals 0. So the degree in the denominator is greater. Okay, so I have y equals 0 as a horizontal asymptote. And my vertical ones are x equals -5 and x equals 1. And there are no zeros. Okay? That means this does not cross the x-axis at all. So now, what I need is one representative point. So, pick an x value. Okay, x equal, well, not a horizontal asymptote. Pick an x value that is not a horizontal asymptote. Okay, x equals 2. Now, what's f of 2? What's the y value at x equals 2? You can plug it in either this one or the factored form. It's much easier to plug it into the factored form. So what I get is 5 over 7 times 1. I didn't. Somebody else did. That was a random point that we picked. Okay? So I put 2 in here. 5 over 7 times 1. So that gives me what? 5 over 7. So f of 2 is 5 over 7. Okay. So at x equals 2, it's 5 over 7. I don't care what the decimal equivalent is. What I care about is the placement of it, and it's above the horizontal asymptote. Let me graph this and I'll get you in a minute. Now, the graph is going to follow the asymptote at the very ends here and here. Okay? So if it's got to follow the asymptote here and it's got to follow that asymptote there, then there is only one way for this to look. Okay? Now, if it exits the screen at the top here, where does it re-enter to the right, to the left of that asymptote? Top or bottom? Bottom. Okay? If it goes out from the top, it's got to go in from the bottom. So now, we're going to go up. Eventually, though, we have to follow the same asymptote, right? Now, are we allowed to cross the x-axis? We are not. So what must happen here? It's going to do what? It's going to turn back around. And again, I don't care where you make it turn. Just make it turn. Follow the asymptote here. Now what? Re-enters from the top here. Okay? So, it exited here and it re-entered there. Okay? So, follow the vertical asymptotes, and really once you get your one representative point, the rest will follow. And as we do more, you'll get more and more. I'm not going to finish this otherwise. Okay? Okay. So here, the zeros, we set the numerator equal to 0. Okay? Asymptotes. Let's factor this. Okay, none of those, the x plus 6 and the x minus 2, don't cancel. So I say I'm going to set those equal to 0. So my vertical asymptotes are x equals -6 and x equals 2. Okay, horizontal. The degree here is 1. The degree here is 2. Higher on the bottom means horizontal asymptote is y equals 0. Okay, now let's go here. Okay, I have 2 at -6 and 2. Okay, another one is the 0. There is a 0 at x equals -1. Here. Okay. Now, when I have a 0, it's best to start from that region. Okay? So now, here, there could be two possibilities. The graph could look like this, Or the graph could look like this. To know what it is, which way it is, I want to plug one other point. Let's pick x equals 0 this time. And I want to find f of 0. Okay? And I'm going to plug it into this one. So if I plug 0 into the numerator, what do I get? 1. And in the denominator, what do I get? Negative 12. So this gives me 1 over negative 12, which is a negative number here. So what does that mean? It was the second option, right? My graph is going to look like this. Well, there is no other way. It's got to follow the asymptote here. It's got to follow the asymptote here. Well, because it's going to cross this and that point. Okay, there is a 0 here. Yeah, this is a negative 1 over 12, so it's here. Right? So how do I make it? I don't.
That's not that point.
This is negative 1 over 12. This is the 0. This was x equals negative 1. There was a 0. Here, x equals negative 1. There was a 0. Okay, so at x equals negative 1, there is a 0. And then at x equals 0, it's negative 1 over 12 right there. Okay. Now, if we go up here, we got to come back here on the bottom and then here. Okay, now I'm going to do a couple more and then I will take questions. Okay? One important thing is this. Horizontal asymptotes. Suppose you have a horizontal asymptote. Horizontal asymptotes only take effect at the very, very ends. It's possible for a graph to cross the horizontal asymptote 1,000,000 times in the middle, as long as at the very ends it doesn't. So for example, it's very possible for a graph to look like this. Okay? That's fine. So you can cross the horizontal asymptote as many times as you want, as long as in the ends you follow it. The vertical asymptotes, not so much. The ends of the graph. Okay, let's do another one. I'm going to do a couple more and then take questions. Okay? All right, so let's do this one. 2. Okay. So find the zeros. Okay? The vertical asymptotes. Okay. Now, horizontal asymptote. I have a degree of 1. I have a degree of 1. When they're the same degree, we take the term that gave me the highest degree and the term that gave me the highest degree, 2x over x, and I simplify. The x's cancel, y equals 2. So now I have y equals 2. The vertical asymptote is x equals negative 2. And there is a 0 at x equals 0. Okay, now, I know that at the end, it's got to follow this asymptote there. I know that to the right, it's got to follow this asymptote here. And I also know that there is one place only that it could cross the x-axis. So now we ask ourselves, how can I connect this end to that end with it passing through the x-axis only one time? Well, this way. Now, if it exits the screen on the bottom here, it must re-enter from the top there. So like that. Okay? Now, the next one, I'm actually gonna, this is too much of a repetition, so I'm gonna move on to here. Point of discontinuity. Okay, so I keep saying, does the denominator cancel? Does the denominator cancel? I know it's always no, no, no. Well, what if they do cancel? If the term in the denominator, I'm skipping one page. If the one in the denominator does cancel, then it can no longer be a vertical asymptote. In that case, it's a type of discontinuity that creates a microscopic break, a hole in the graph, okay? So this happens when the denominator is able to cancel with the numerator, okay? So when anything in the denominator is able to cancel. So let's factor and simplify this. F of x is x minus 2, x plus 2, over x minus 2. Now, normally we would have said, oh, x minus 2 is just going to be a vertical asymptote. But no, because it cancels with the numerator. Okay? So now that x minus 2 is no longer a vertical asymptote. Okay? So once I've simplified, I have f of x is equal to x plus 2. Okay. Now it says to find the zeros. And it says to set the numerator equal to 0. This is of the simplified fraction. So now all I have is x plus 2. Set it equal to 0. And how much is x? Negative 2 is my 0. Okay, vertical asymptotes. In the final simplified version, is there anything in the denominator? No. So there are no vertical asymptotes. Okay, any holes? Was there anything in the denominator that did cancel? Yeah, the x minus 2. So I say x minus 2 is equal to 0. X equals 2. Okay, find any horizontal asymptotes. Are there any horizontal asymptotes? What's the degree in the top? The bottom? If the degree in the top is higher, then there are none. Well, even the simplified one, this is over 1, right? So again, this has a degree of 1 over a degree of 0, so nothing. Okay, now, now we're going to graph. When you graph the simplified version. So in this case, it's f of x equals x plus 2. What does that look like? What graph do you get when you graph that? A straight line, right? You get it's a linear equation. Okay, now there is a hole at x equals, what did we say? 2. But where do we place it? Y equals what? So if, in pretending like there was no hole, if we were to plug x equals 2 in here, what would the y value be? Huh? 4. Okay? So at y equals 2, and y equals 4 and x equals 2, there's a hole. Where is the 0? At negative 2. And this is just a line, so it looks like this. Okay? That's where the hole is. There's a hole. How else would you draw a hole?
Why is it not colored in?
When I factor this, let's see, x minus 3, x plus 2. Okay? So the x minus 3's cancel. So f of x is equal to 1 over x plus 2. Now, it says find the zeros. Set the numerator equal to 0. Well, we're going to use the final version. 1 equals 0. That doesn't work, so there are none. Okay, vertical asymptotes. Is there anything in the denominator that did not go away? Yes, x plus 2 equal to 0. X equals negative 2. Any holes? Anything that did go away? Right? X equals 3. Horizontal asymptotes. The degree on the top is 0, on the bottom is 1, so it's what? Y equals 0. Okay? Because when the degree in the denominator is higher, it's always y equals 0. Vertical asymptote, x equals negative 2. I'm waiting. What am I waiting for? Okay. So the whole is at x equals 3. What would the y value be? Well, it's 1 over 3 plus 2, 1 over 5. So at 3, 1, 2, 3, and 1 over 5, right there. Okay? Now, so I know there is a hole there. That means the graph must pass through there. Okay? Here, at y equals 1, 2, 3, and 1.5. So that's very close. Now, are there any zeros? Does this cross the x-axis? There are no zeros, right? This doesn't cross the x-axis. But it must pass through this region since the hole is over there. And it's going to follow the asymptote, the horizontal asymptote on the right side. So it's going to look like this. Okay? And here. I didn't have to pick points. Okay? This homework is due Friday, by the way.